Well, thank you everyone for joining us for this quick discussion on how to select and deploy HOBOnet soil moisture sensors. In past webinars and discussing a lot of these tools, we've got some feedback regarding, looking for help on how to actually choose or look at the differences between the specific devices. So I'm hoping that this is interesting and different enough version of our typical webinar on soil moisture. It should run approximately 40 to 45 minutes, and then we'll have time for some questions at the end. Some housekeeping items to get in order. So this webinar is being recorded. Jessica will send everyone a link to the recording in the next 2 days or so. You've all been playing with the questions box already. If you do have any questions, please feel free to enter them into the questions panel, and we'll try to get through as many of them as we can later at the end of the presentation. However, if anything does come up after the webinar that you thought of, just be sure to answer the quick survey at the end of this presentation. Select that you would like to have someone reach out to you, and we'll be sure to assist you with any questions you may have. Again, I'm Richard Rodriguez. I joined Onset back in 2019. After this year of COVID, it seems like a lifetime ago. I'm leading the work on outdoor and agricultural products. For anyone new to Onset, Onset's been around we actually just had our 40th year anniversary. Believe it or not, we've been around since 1981 and have been leaders in data logging and sensors for 40 years. Our products are time tested and trusted for reliability and to perform as intended in some of the harshest conditions around the world. We've got a great history with a lot of researchers in different areas, including agricultural research. And over the past few years, we've started to focus more on the commercial side of agriculture. We do have a global network of distributors, so our products are available to you anywhere in the world. So for topics today, we'll start off with a quick overview of why measure moisture in soil, which if you joined, you probably already have a reason to want to. So that should be a quick overview. We'll look at soil moisture options, how to look at performance, cost, different types of soil moisture sensors, and then we'll get into the actual HOBOnet soil moisture sensor options, which we now have quite a few compared to where we were a little over a year ago. We'll make some recommendations regarding deployment, and then we'll look a little more at HOBOnet and how that, what HOBOnet looks like. So this will be a little more focused on our products as opposed to just application. And so why measure soil moisture? Why would we be interested? Well, direct measurement of water content in soil to verify the availability of water to plants can really help you in being more efficient with the use of water in irrigation. You can water based off of how much water is available to your crop, or based on the demand of the crop, rather than using a fixed schedule or relying on a visual inspection of plants. I've talked to some farmers that really their way of planning irrigation was to look at leaves or look for signs in their crops, which in many cases signal that there was already some stress being felt by the crop, which then had an impact on yield. So really by better understanding available water, or the water that's available to the crop, you can improve the outcomes, whether that is by avoiding stress, or in some cases, in the case of grapes, you may be looking to use deficit irrigation to achieve a better outcome. And these tools can help you with that. And then, of course, we know that soil isn't always uniform. roots really extend through multiple layers of soil, which may retain water differently, and you may want to check that water may be look for water that may be available at deeper points in the soil. Water feels the effects of evapotranspiration much more in the top couple of inches of soil. So, just by looking at the soil or feeling the soil at the top may not be a good indicator of water that is available to your plants. In other cases, I'm thinking of a barley grower that in order to increase yield, he stressed the plant early on in its life, forcing the roots to grow deeper, to seek water deeper into the soil, and he did that by monitoring, looking for moisture deeper down, leading the root length early on in the crop's life. All right, so if you're looking for soil to monitor soil moisture, what should you be looking for? They really come and there are a lot of options. A lot of sensors seem to be doing the same thing, but really range quite widely in terms of price point. And as you dig in, some of those differences start off with accuracy. So that may be the first question you ask yourself is how accurate do I need this device to be? Accuracy meaning how well the sensor will hit the target or when measuring soil moisture, or how closely to the actual amount of moisture will that reading be. Typically, those devices with higher accuracy will come at a much higher cost. So you'll want to understand how accurate you need this device to be. In practice, in practical applications, perhaps precision may be more important to you than accuracy. Precision being how repeatable the results are from sensor to sensor or within the same sensor, measurement after measurement. How repeatable is that? So in order for you to do proper planning for irrigation, you may be able to give up a little bit on accuracy as long as the results are always consistent with your expectations. And then what type of measurements are you looking for? Are you looking for just soil moisture results, or do dielectric readings matter to you as well? Would you also like to understand temperature in the soil, or is electrical conductivity something that you would value as well? These are all features that may be a value or not to you, but would have an impact on price and performance of the product. And then finally, volume of influence. This is a big one, the one that we put a lot of emphasis on. Depending on what you're looking to get as a result, do you want to understand what soil moisture looks like at a small point in the soil, at a very finite point in the soil, or are you looking to understand what soil moisture looks in a greater volume of soil while minimizing the number of sensors that you actually have to deploy? Larger volumes of devices with larger volumes of influence are better when you're looking to account for soil variability. You've got different variables in soil, such as different soil types, rocks, and all that could impact your readings. And so the one way to get around that is to look for a device that has a large volume of influence that will kind of average that out and give you a nice overall picture of soil moisture. And then when you're looking at costs, you've got different things to consider. One, the complete cost in terms of initial setup, not just for the device itself, but what other supporting equipment do you need? Then you have the issue of lifetime versus replacement. Some devices may seem very inexpensive, cost you around $40 or $50, but then you're going to deploy them, have to replace them year after year, typically on a yearly basis, and that cost can really add up, not just in terms of what the device will cost, but your time, the labor spent in actually getting these done. And where a device that may cost you a little more on day one can be deployed year after year, maybe left on site for 5 years at a time without even having so much as replace batteries. That equation can equal out for you rather quickly. In terms of maintenance, is there anything that you need to do to keep up with the quality? And then ease of use. So how, for example, how do you collect the data? Is it something that will provide you a view of soil moisture remotely, or is it something that you have to be on site to or travel to the actual location to get that data? So in terms of types of soil moisture sensors, we have three main types that in terms of the data they'll provide you. So you've got those providing you volumetric water content, basically the ratio of water volume to the soil volume. And these will typically be provided in meters cubed over meters cubed. A lot of growers then like to convert this to percentage saturation. So it's a relatively easy equation if you understand your soil. If you know what type of soil you have, you do some simple experimentation, you can do this conversion rather easily. And then soil water potential, a favorite in terms of growing, because this measure doesn't tell you just how much water there is, or it doesn't actually tell you how much water there is. It does tell you how much free water there is for your plant to pull. It basically gives you an indication as to how much stress is required of the plant, or how much tension there is on the plant to pull the water from the soil. This is a measurement of interest, mostly because it's independent of soil type. So different soil types will retain water differently. So, for example, sand will give up water much easily, so you need less water for the plant to sustain itself. It also clears hurdles in terms of salinity and things of that nature. And then tensiometers are instruments designed to get a similar type of water potential measurement. They're just done differently and more of a local type of device. Digging in a little deeper into the comparisons between the two types of measurements, volumetric water content or soil water potential. If you look at the graph on the left, you'll see on your y-axis, you've got your matrix potential, so the amount of tension required from the plant to absorb water, and on along the x-axis is the actual amount of water available as a percentage of volume. And the four lines represent four different types of soil. So you've got sandy soil, loam, peat, and clay. So along the x-axis, as you move left to right, that indicates there is more water available. So what you'll see is that for sand, you really don't need a lot of water to provide a sufficient amount of water, easily enough to avoid wilting point. So you'll see up here your wilting point for plants, and then field capacity down here. So sand will reach field capacity with much less water, and will give up that water a lot more easily compared to clay, for example, which requires a lot more water. You need to be at about 55% by volume of water in order to be at field capacity. Another way to look at it is on the right-hand side, another way to look at the comparison between sand and clay, for example. Your field capacity is the highest point at which you would want to water your fields. The lowest level of that you would want to get to is your management allowable depletion. So for sand, that's 5% of water by volume. For clay, that's 40%. And your maximum would be 10% for sand, 50% for clay. Now looking at the overall toolbox in terms of soil moisture measurements with HOBO products, we've done quite a few additions in the past year to our portfolio. We've added a soil water potential option with that we'll get into cover in a few minutes. Quite a few options in terms of moisture, soil moisture and temperature combination, and then soil moisture, temperature, and electrical conductivity, including a version of with a multiple depth soil moisture probe. So the first set options that we'll cover are those that have been in the portfolio for the longest, the well-known Decagon EC5 and 10HS. These have been staples, well-known in the industry for many years. They've been part of our portfolio for several years. They're available in both a wired plug-and-play option as well as in a wireless sensor option. These are best for applications requiring a low initial cost to purchase. They're easy to deploy. They have good accuracy, but they are basically printed circuit boards, so they're not well suited for all applications. So if you've got an application with rocky or sandy soil, installation, a lot of movement above that sensor can cause damage to the sensor itself, meaning that you're going to get 1 to 3 years out of it before you would have to replace it. So great if you're just trying to do a check and don't need longevity. But if you're looking for something that you can leave out in the field deployed, we have other better recommendations for you. And with that, we'll cover the HOBOnet T11 and T12 sensors. So these, we basically integrated meters, Terrace 11 and 12 into our portfolio. We selected these for several reasons. So one, that they have a large volume of influence, relatively large volume of influence in a very small bulletproof package. So that's something that really drew us to them. They're something flexible because of their size, but they give you quite accurate results because of that. They have a volume of influence of about 1 liter. In terms of installation, they have sharpened stainless steel probes, as you can see in the image. Those make installation quite easy. You basically can push them into the soil. Those are robust, so you don't have to worry about them getting damaged, like something that could happen with the EC5 and 10HS. They've got great precision, so they've got very low sensor to sensor variability, and they minimize, because of the frequency of the signals they use, they minimize the effects of salinity in the soil. For the T12, in addition to giving you volumetric water content and temperature readings, that will also provide you an electrical conductivity measurement. Pricing for these start at $395 and go to $450. In terms of installation, they have your typical type of installation where you're going to have to dig a hole or auger out a hole, get the reach out down to the desired depth, and then push the sensor into undisturbed soil. Then you're going to want to backfill the removed soil. And always when you do this, the trick is to replace the soil in the same fashion it was removed, meaning that you want to lay out the soil so that if you have any variability in soil type with depth, you're matching those soil types again as you backfill the hole, and you'll want to pack the soil back to match the density of undisturbed soil around it. The HOBOnet T21 sensor, this is a soil water potential and temperature all-in-one sensor, and this again will depict how easily water is available to plants. So we'll measure stress. It's a long-lasting device and maintenance-free. The ceramic discs are coated in the durable epoxy, which makes it capable of withstanding long deployments in ground without any needing to refill any devices. You don't have to worry about freezing conditions. This device can be left out year after year without having to worry about it. Now, with that said, because these sensors require good contact between the sensor and the soil, if the soil it's in actually freezes, that can create air gaps between the soil and the sensor, which would create erroneous measurements. However, after the soil thaws out around the soil, everything would go back to working as intended. Then they feature a wide measurement range from 2,000 kilopascals to negative 9,000 kilopascals, which basically covers the range your crops would ever want to be in. In terms of deployment of this sensor, it's very similar to that of the T11 T12, where you're going to auger out a hole. But one point of distinction is that you'll want to actually create a slurry of soil and water, pack that around the sensor disc just to make sure that you create good tight contact between the soil and the sensor itself, and then place that in sideways into the undisturbed soil. Always making sure that it's the disc is vertical and not horizontal. If you leave it horizontal, basically it will create a surface that will trap water and create a condition where you have greater moisture than the actual soil around it would have. Whenever you're deploying a soil moisture sensor, we always recommend leaving an extra loop, a little extra cable to create some slack, and so that in the event that you tug on the cable when backfilling the hole or connecting any wires up top, you don't inadvertently move or dislodge the sensor in any way. And finally, we come to the HOBOnet Multidepth soil moisture and temperature probe. This one actually has the largest volume of influence per measurement section. So there are three reasons why we selected to include this specific probe in our portfolio. One, it has a very large volume of influence. So where the meter offered a 1 liter volume of influence, this one has a close to 2 liter volume of influence per measurement section. And then it does come available in 3 different lengths, from 18 inches to 35-inch long probes. A second reason why we selected this is that it is different than other probes in the way that it measures soil moisture or across its section. A majority of soil moisture probes will have discrete sensors along the probe. So say every 10 centimeters, you'll get a sensor and you'll get a reading at that specific point. The HOBOnet Multidepth soil moisture sensor actually has discrete sensors along its length as well, but each sensor, which takes up 15 centimeter segments, those measure soil moisture along their entire length. The reason this is important, or this is relevant, is we know that soil isn't always the same. You've got different soil types across different depths. You may have large rocks, as you see here in the picture, and let's take the case of having a large rock placed in proximity to a probe. If you look at the probe on the left, you see this rock is butting up against one of those sensors. So the soil moisture readings obtained by this sensor, this third depth, are going to be greatly impacted by the presence of this rock. On the other hand, our probe, because it measures across the entire length of the probe of that sensor segment, you get a larger volume of influence, and so that the information obtained, or the readings, the measurements impacted by that rock get averaged out almost, because that rock will make up a much smaller percentage of the total volume of influence. Then these probes also have highly repeatable results. They have a very high frequency of measurements. so that they're capable of filtering out any noise, any disturbances in the soil that would cause any distortions in your readings, so that when you make irrigation decisions, you're sure to be using quality data. And then the third reason why we selected this probe is how easy it is to install without actually having to excavate or auger out any holes, which we'll cover that in a few minutes. And then on top of all of that, all those great features, the price points are relatively low compared to other similar probes in the market. These are priced very aggressively, starting at $690 and going up to $990, depending on the length that you select. Because durability matters to all of our customers, we also wanted to ensure that we selected a device that was capable of withstanding any real life hazards. So this device actually has an epoxy sealed, completely epoxy sealed circuit board, and then an outer polycarbonate jacket. So if that polycarbonate jacket ever cracks for whatever reason out in the field, and there's any moisture that actually seeps into the sensor, that epoxy will still be protecting the circuitry, so you won't have to worry about having to replace that right away. In terms of deployment, again, a great thing here is that you don't need to auger out any hole, which becomes troublesome to actually do it correctly and then ensure that you pack up the hole back to its original state. And with that, we're actually going to try to show you a portion of the video we created to demonstrate how easy it is. So I'm going to show you a video of the minute or so that it takes to install this. There we go. So we offer a slide hammer and pilot rod to match the length of the device you select. And with that slide hammer, it takes approximately a minute to go the full 35-inch length. Now, before removing the rod, it may be helpful to pour a little water around the hole to help the soil around the hole adhere a little more to avoid it backfilling as you remove the rod. To remove the rod, all you're going to do is the opposite motion to inserting the rod. So easy that the marketing guy was able to do it the first time around without having practiced first. One lesson that I learned after doing that on a day where it was 103 degrees out is bring extra water if you're going to have to pour water as part of the deployment. But again, that entire deployment took about 90 seconds, so about 60 seconds worth of the slide hammer, and then pushing the sensor into the ground didn't take much longer. Now, one common question we get is how many sensors do I need? So this really is hard to just provide you a rule of thumb, but we can give you some guidelines and always work with you on determining that by discussing the details with you. But the first thing really is to look at, one of the first things to look at is what type of soils are you going to, or how much variability in the soil type are you going to encounter? So if your fields are relatively uniform, the type of soil you have will be consistent throughout, then you can cover a pretty wide area with a single probe. However, if you've got changes in the soil type, you'll want to have sensors deployed at each point where you'll have some soil representative of that area around it, so that you can better plan for the retention capacity of that soil. This soil will only vary from place to place. It will actually can also vary with depth. So if you expect large variations in soil type with depth, you'll want to deploy additional sensors along the root zone so that you have an understanding of how much moisture is available at different points of the root zone. Topography is or the difference in elevation can also cause some needs to add additional sensors. So if you've got water running off from one area into another, you'll know that you'll have differences in the amount of moisture available at different spots. Types of irrigation will also lead to different requirements in a number of sensors. We can offer some guidelines for different types of irrigation. However, in the event that you're using a pivot, for example, you'll want to at minimum have 2 points of measurement, one just before the start of the pivot and one at the end of the pivot. The reason for this is to ensure that your planning is correct, given the amount of time that it takes for a pivot to complete a turn. Some things to keep in mind in terms of deployment when backfilling your hole. Always be careful with how you're returning the soil back into the hole. We recommend having a plastic tarp on site so that as you pull soil out, you can lay it out in the order that you pull it out. So then when you're backfilling, you can be sure to place different segments of soil back at the same depth you pull it out of, so that the soil immediately surrounding your sensor will best match or represent the soil in that vicinity. Proper cable management is a must. So we recommend keeping cables tight to a post just to avoid having any tools get caught on the cables and ripping them out. That's typically the source of a lot of damage for our customers. We recommend protecting the exposed areas of the cable. So from the radio down to the soil, you'll want to protect the cables from any wildlife. We find rodents, deer tend to come out and chew on a lot of these cables. And again, you'll want to leave some slack in the ground buried when you install the sensor. And then look for the unexpected. Make notes of anything that you notice in the soil. You may have signs of burrowing animals. There, some tunnels left by rats or moles could cause distortions in your measurements. If you notice any layers of clay that can trap moisture, that'll be important to understand, so that when you're looking at your data and you realize that, hey, 18 inches down, there's a spike in moisture that's pretty consistent and constantly there, you'll know why that is. You'll know that there's a reason for moisture to get trapped at that point. And now to look at HOBOnet. So everything I discussed is available as part of our HOBOnet portfolio. HOBOnet is a wireless sensor network. So it's something that we created to provide a cost-effective way to remotely monitor multiple points in a field without having to run wires. So this wireless monitoring system, it gives you, the devices give you a range of about 1,500 to 2,000 feet line of sight from the station to sensor or from sensor to sensor. So these sensors create a self-healing mesh network, and so they can relay the signal from one another to get to the data logging station. So with say 1,500 to 2,000 feet, you can get anywhere from 7,500 to 10,000 feet from the sensor, from the station to the farthest out sensor. This will also help you get around any obstructions such as buildings or trees, hills that you have on your property. So they make it easier to ensure that you can get a strong signal to always get your data. And then they're solar powered. Everything from the station to the sensors themselves have batteries with solar power, their own built-in solar power to recharge those batteries, ensure that you can have these devices deployed without ever having to worry about maintenance. At the heart of HOBOnet, you would have your two options for stations. You have your low-cost RX 2100 and the RX 3000. The RX 2100 is the right solution for a majority of applications because of its low cost and it's very small, easy to deploy. The RX 3000 just provides a few more capabilities. Say if you want to not only have wireless sensors, but also monitor water level in a pond or water flow for some channels. This can do that for you. You can also add in a relay to initiate pumps for irrigation, for example, and then all your data would be viewed on HOBOlink, our cloud service, which will allow you to create different views for your data, enter your own thresholds for different sensors so that you can get alerts to any critical conditions. You can have a Google Maps view of your sensors and where they're deployed with a quick summary of conditions there. In terms of cost, the RX 2100 with the wireless capabilities starts at $770, and that includes a built-in panel, built-in solar panel, that is. The RX 3000 runs a little more expensive, starting at $899, but then you would have to add a solar panel for that, and then you would of course choose your own sensors. We only covered soil moisture sensors here, but we have a wide suite of sensors, so you can equip a complete weather station. You can have that weather station feeding data into NUA. You can monitor everything from your farm to your cold storage facility, greenhouses, different equipment. All on one system, all off of one station, all running off of a single data plan, which we offer different levels of data plans, starting at $150 per year and up for 3G or 4G. You have an option for to use your own SIM card. So if you have your own data plan for your business, that's something that you can build in. Use with our stations, assuming there's a match of the cellular type, and but then we also have Wi-Fi and Ethernet versions. That brings me to the end of the webinar. I'll open this up to any questions that you may have, but I'll point you to the screen where we list off contact information for our global sales leads. So again, regardless of where you are, we have someone there to help you. My email address is right there at the top. Please do not hesitate to reach out if you have any questions or comments, want to discuss anything we covered here or didn't cover here. I'd love to hear from you.
Hi, Richard. We do have a couple questions here. First one is, what kind of maintenance could someone expect these sensors might need?
So in terms of maintenance, there isn't much other than after a couple of years of deployment, if you're looking for high accuracy, you may want to check for drift. However, a lot of the sensors we covered here are actually designed to be deployed for several years. In the case of the metered Taros sensors, I think they have a 10-year lifetime to them. But then outside of that, you may have to replace the rechargeable batteries after 4 or 5 years.
Great, thank you. Another question we have, can these sensors be connected to Arduino-based platforms for data logging?
So the sensors themselves, I assume, can be. We don't. So we build or incorporate the third-party sensors into our wireless system. So you really wouldn't be looking at the HOBOnet solution for that. You'd want to reach out to the actual sensor manufacturer, which we could point you to in order to, if you're looking to create your own solution. Other than that, HOBOnet would provide you the turnkey solution.
Okay, thank you. Another question here. Can I use the HOBOnet soil moisture sensors to monitor maize, which have roots that can go up to 1.2 meters?
Yes, so you can do it in different ways. So you can select one of our single point sensors and deploy them at multiple depths. So for each position where you want to get readings, you could do, say, three different depths, and set up, say, 3 different HOBOnet T11s. The cables will allow you to reach that deep. The multiple depth sensor that has it's about 90 centimeters. The longest version is 90 centimeters deep, so that will get you close to that 1.2 meters. Or you can also you bury one slightly deeper, so you can start it not at the surface of the soil, but push it down to get to the 1.2 meters.
Great, thank you. There's a question from Lorena here. For peat environments, which kind of soil moisture sensor would you recommend?
Good question. I want to say I'd be inclined to go with the T11 or 12. They give you some flexibility in terms of calibration, but definitely that's something where you would definitely want to look at doing your own calibration. So these sensors are all factory calibrated to work in most mineral soil types, but for something that specific, you'd want to do your own calibration, and there are tools for that.
Great. Okay. We have a question here from Chuck. Chuck, thank you for your question. He's asking about supporting any additional APIs, but he's actually talking about custom dashboards, I believe, for reporting with the data.
So we do have, you can build out your own dashboard in HOBOlink to create your own views. However, if you have your own server, your own system where you want to pull your data into, we do offer, and we do have an API that will allow you to pull data from HOBOlink directly into whatever your platform would be.
Okay, thank you very much, Richard. I think that might be it for now. Oh, we've got some more coming in. Okay, so we have a question from Ian here. Ian, thank you for your question. What is I know you mentioned precision and accuracy, but what is the minimum soil moisture measured? He's thinking about an application to measure soil moisture in a desert environment over large areas. So what is the minimum soil moisture measured?
So that depends on the tool that you're looking for. So each of these sensors will have its own range. So looking at the, let's look at the, when you say multiple wide range, is that wide depths or single point, single depth?
Over large area, so he's talking about areas.
So the range, right? So the range, for example, for the Teros is 0, so no moisture to 0.7 meters cubed per meters cubed. So that's probably in that environment. That would be my recommendation. I would stay away from the multiple. The probe would be very difficult, I think, to install in that type of environment. But it would also give you a similar range. The Teros, the T21 would not go that low. It would not provide you high accuracy at that low level of moisture.
Okay, thanks, Richard. We have a application question here from Nathan. He's wondering if these soil moisture sensors, I actually wonder if it might be another one of our products, but when ocean water inundates a salt marsh lagoon, would any of these work if the soil is already wet or saturated? Could we still discern when additional water comes in and rests on top of the soil?
That's I would want to. I don't feel comfortable answering that right now. I'd like to dig into that a little deeper with you. So Nathan, if you could, select that you're cool with us reaching out to you, we can work with you on that. It really depends on the amount of on what the change in soil moisture will be. So if we'd have to be able, the device would have to be able to pick up on going on a raising or a rising soil moisture level. So volumetric water content would have to go up. If you're saturated before the ocean water comes in, then the soil moisture sensor would not be the way to do that. But we have other devices that you could pair up with this to tell you when this happens. So we can work through that with you. That would actually be a lot of fun, I think, to work through.
Great. Yeah, Nathan said we can get in touch afterwards. Thanks, Nathan. So we have a question from a friend in Brazil, wondering about the accuracy. Is the accuracy similar for the wet and dry range of soil moisture?
Again, that is sensor dependent. So it really depends on what sensors you're looking at. But the accuracy varies within for different ranges of soil moisture. And those are all detailed out on our spec sheets. So for different, so for example, the T21, that higher accuracy is given where you expect your crops to be. So we give up a little bit on the extremely dry area. Also, as you really dry out soil, it tends to create gaps between the soil and the sensor, so you're going to lose some accuracy there. But again, that's really dependent on the soil, on the sensor type.
Another question here from Etta. What would you recommend for Arctic soil monitoring?
So interestingly enough, we recently worked through an Arctic study for a Canadian customer, and he selected actually a combination. So he went with some T21s and T12s. The larger number were on the T21. So he was actually looking to see how water availability changed with a thawing environment. And he had to choose a device that was capable of withstanding frozen soil, obviously. And he understood that when soil freezes, that the data may not be accurate because you create air gap separation between the soil and the sensor. However, when you get that thawing, you get that's when you actually get the best contact. So those devices were deployed at the perfect time for that data. So those would be my recommendations, mostly because that's what we went with.
Great, thank you, Richard. And Richard, that is all the questions I see for now.
Great. Well, then, thank you, everyone. I hope everyone enjoyed the webinar. It was a pleasure for me. I hope to hear from everyone soon, and enjoy your week.